This is a series of multiple choice questions on the AQA A-level chemistry topic, amount of substance. This is set 7. There are 5 questions within here, and I'm going to recommend that you pause on each question, try and come up with the answer for yourself and see how you do. So let's get started with the first one. And if you've gone through the other videos, you'll see there are many in this vein. Which of these contains the most molecules? So we've got a series of masses and we've got compounds that we can work out the MR. If I then go through and think about the considerations, the first thing is that you'll notice this is in kilograms, this is in milligrams, and these two are in grams. I would be converting all of them to grams so that we can work out. And I've put the numbers on the right-hand side. So for A, 31.1 grams divided by 44. B, 29.6 over 28. C is 22 grams over 32. And D, 13.3 over 48. And with this question, you could go through and do all of those calculations, but you could actually potentially do this much more quickly. Because one of the things that stands out is that when I take my mass and divide by molecular mass, B is the only one where the answer would be greater than 1. The number on top is bigger than the number on the bottom. So that takes us to answer B. Let's try the next question. And on here we have got a volume and we've got a concentration, and we are working through with that to find out the volume of water we need to add to dilute my hydrochloric acid from one concentration to another concentration. So let's begin by calculating the number of moles of HCl that we have in our sample. I've got my concentration provided, I've got my volume which I've converted into decimeters cubed. That takes me to 5 by 10 to the minus 5 moles. Now, from there, I want to work out the volume that I would need if that's how many moles I have in my new concentration, 5 by 10 to the minus 4. So 5 by 10 to the minus 5 over 5 by 10 to the minus 4 is 0.1 decimeter cubed, which is 100 centimeters cubed. However, we're not asked what the volume should be, we're asking how much we need to add. And we already had a 5 cm cubed sample. So the volume that I need to add of water is 95 centimeters cubed. And the correct answer is B. Let's move on to the next question now. And this question does rely on you knowing that 1 mole of any gas will occupy the same volume if pressure, temperature are the same. And that links to what we know with the ideal gas equation, actually. If I look at this, I've got a 1 to 3.5 ratio. And from there, I then know that if my 20 cm cubed of ethane burns completely, 20 cm cubed would require 70 centimeter cubed of oxygen. Now, I started with 100 centimeter cubed of oxygen, and that tells me that we have 30 centimeters cubed remaining. What I'm then going to do is look at my mole ratio of ethane to gas. And it does tell you that this is above 100 degrees C, so my CO2 and my H2O are both gases. Now, 1 mole of ethane makes 2 moles of CO2 and 3 moles of H2O. So my ratio of ethane to gases is 1 to 5. Now again, I know that 20 centimeter cubed of ethane reacted. So on a 1 to 5 ratio, that means I've made 100 cm cubed collectively of carbon dioxide and water. So I've made 100 cm cubed, but I still had 30 cm cubed of oxygen remaining. That means the final answer is 130 centimeters cubed. Correct answer is D. Let's try the next one. And this is a relatively straightforward ideal gas equation question. So I'm going to write out the values that I have. I've got my pressure, I've got my volume, I've got my number of moles I need to work out. I've got the mass of oxygen. I've got to remember that oxygen is diatomic, so its MR is 32, and we can work out what N is in a second. R is provided as well, 8.31. Now my next step is to do any calculations or conversion of units. So you can see here I've converted my pressure into pascals, my volume into meters cubed, my number of moles has now been calculated. I've got my 4 figures to put in to PV as nRT rearranged. T is PV over nR. So I'm now going to substitute those figures in, and I've got my 101,000, my 1870 by 10 to the minus 6, they go on the top. I've got my number of moles and my R value that go on the bottom. And if I go through the whole of that calculation, I get to a value of 334 Kelvin. Now you'll see here they've given you an option of 334,000 Kelvin. It's working on the basis that you will forget to convert some of your units. Moving on to the next question. And on this one it looks slightly unusual, but it is reacting masses. We're starting with RCOOR and we're ending with RCOOH. And we are starting with 1 gram of the RCOOR. So let's build our table. The species we know about and the species we want to know about. We know we made 0.5 grams, but it's a percentage yield question as well. So we need to find out what the maximum theoretical mass of RCOOH would be. So I have 1 gram of RCOOR dash. Its MR is 150 as provided. 1 over 150 gives me 0.006 recurring moles. My mole ratio from the equation is 1 to 1. So if 1 mole makes 1 mole, 0.006 recurring makes 0.006 recurring. And I've got an MR for RCOOH. It's 100. So I've now got my MR and my N that I can multiply together, and I get to 66.6, rounded to 67. The correct answer is C. That takes us to the end of this video. Thank you for listening and goodbye.